What's going on, you guys? So today we're going to do climbing stairs, and so this problem, so you're climbing a staircase. It takes n steps to reach to the top. Each time you can either climb one or two steps, and how many distinct ways can you climb to the top? So, okay, um, let's think about this. Let's say there's 0 steps, n equals 0. So we're just going to return 0. Let's see. Um, and let's keep track of this as well. We'll keep an array. So n equals 0, 0. Okay. What about n equals 1? There's one way. You can just take one step. So there's one way. 1 and 8. 1. Okay, and now what about 2? N equals 2. So we can take 1, 1, or just 1, 2 step. So there's two ways. 2, okay. 2. And now how about 3? N equals 3. And it does help to see, so 1, 1, or just 2. And then for this one, we can do 1, 1, 1. We can do 2, 1, 1, 2. That's all. Yeah, so 3 ways for 3. 3. Okay, what about 4? N equals 4. Okay, so we can do 1, 1, 1, 1. We can do 1, 1, 2. We can do 1, 2, 1. We can do 2, 1, 1. Or we could do 2 or 2. So how many is that? 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5. Okay. Okay. All right, let's do one more. So, are we noticing any patterns? This is the sum of the previous two. This is the sum of the previous two. Okay, let's do 5. 1, 1, 1, 1. 2. What else? 2, 3, 4, 5. Okay, what else we can do? 2, 2, 2, 1. What else? 2, 1, 2. 1, 2, 2. Okay, I think that's it. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 is the sum of the previous two. So say if, so what's our formula here? So climb stairs n equals the previous two. N minus 2 and minus 1. And we're just noticing this formula by just writing it out by hand and just seeing that this case holds. And there might be some mathematical proof for this, but we're just gonna use a numerical. So we can just run a bunch of examples and plug it into this formula and see if it holds or not. So we're going to return oops. So we're going to return this, and then we have to think about what are our base cases. So if n is less than 1, so 0, -1, or whatever, we'll return 0. If n equals 1, we'll return 2. Oh, sorry, 1. If n equals 2, we'll return 2. Okay. And then from then on, it's just the sum of the previous two. Okay. Let's see if that works. Oh, this is gotta comment this out. Okay. Oh. Okay. Oh, what's the problem there? Stack Overflow error, right? So let's think about the time complexity of this and see why we got this Stack Overflow. So if n equals 5, how long will it take us to figure out for n equals 5? Let's think. So for 5, we have 2 calls to climb stairs, and then for 4, we'll have 2. So for each n, from 1 to n, we're going to have 2 calls. So it's going to be 2 to the n runtime, time complexity. Space, also 2 to the n. Because we have to put all those climb stairs calls on the call stack. What? Okay. So O of 2 to the n, space and time complexity for this one. So we're let's think, are we duplicating work? So if we plug in climb stairs 5, we're going to return climb stairs 4 and climb stairs 3. Climb stairs 4, we're going to return climb stairs 3 and 2. So there's the duplicate. We're going to call values more than once. So we can, if we add memoization, we can take this down from 2 to the n space complexity. So memoization. Memoization should be, so we're only going to need to call climb stairs n times. And we reduce all the redundant calls to climb stairs on the call stack to just n. Okay, so let's add memoization. So var let's call it a memo. We'll use a hash map, mutable map of, it'll be int and int, and we'll say if memo n does not equal null, we'll return memo n. Else, we'll create a result, an intermediate result, and we'll return the result and set that value in the memo. Okay, so this should go down to O of n space and time complexity, because the calls, so we're still calling climb stairs redundantly, but those calls are O of 1. Wait, let's think. Oh, 5, let's see, climb stairs 5, return climb stairs 4 and 3, 4, climb stairs 3 and 2. Okay, let's see. Okay, so we need to assure that this is not null. What's the issue here? Stack overflow. Interesting. Very interesting. Let's see what's going, let's see what, let's print out. Let's print line. Let's print and so this should be reducing until it hits, oh, we're just, oh, what am I doing here? Okay. I don't have any return statements here. Okay. Okay, so there you go. There's, with the memo, here's the question. Let's see here. Just want to see what I get here without the memo. Okay, it's just not able to run. So it is running successfully, but the stack overflows. Okay, so that's top down with memoization. So now let's think of bottom up. So bottom up, here's our bottom up formula. So climb stairs, we're just gonna add the 2 previous values. So this one will create an array of size n. We'll set memo of 0 equal to 0. Here. For I in 0 to 2, we're just going to set memo of I to, and so we're using this formula right here. We're going to set memo of I equal to I. Okay. This is our base case. Okay. And now we need to build the rest of the memo. So for I in 3 until n, memo of I equals memo of I minus 1 plus memo I minus 2. And let's say n plus 1, right? Because the last value this is going to take is going to be n minus 1. So we want to do n plus 1. So the last value here will be memo of n. And so then we can just return memo of n. Okay. And so let's think about what is the time and space complexity. Bottom up. Memoization. Let's think. So O of n, time complexity. And so if we do n a million, then we need to create an array with size 1 million. And all that has to sit in the computer's memory. So is that O of n space complexity? Or is that O of 1? If you guys have any opinions on that, O of n versus O of 1 space complexity, let me know. But we're only running through, we compute each value in memo once. And so this only takes us O of n time to do that. So let's see here. Index out of bounds. Okay, let's just do, wait, let's think. So what are we doing? I is 1. Okay, we'll just keep bar. Okay. Okay. It looks like it used the same space as the top-down with memoization. It's interesting. It is a bit faster than top-down with memoization. Yeah, there you go, guys. There's a few different ways to solve this. Starting with realizing that each after 0, 1, 2, we can use this formula where climb stairs of n equals the sum of the previous two. And we figure that out by just doing the manual work and seeing that, hey, after we get to 3, it's just the sum of the previous two. Yeah, that has been climbing stairs, you guys. Stay tuned for the next one.